This presentation is going to go through a quick PowerPoint just as a quick overview, and then we'll just kind of go through some examples and walk through the new software and show you guys what we're working with. I see a lot of familiar names and a number of names that I'm not sure where they came from. So welcome to those I know, and I'm glad to meet all the ones that are new acquaintances here. So this agenda for this webinar, I want to give a little bit of a background just on our company for those of you that don't know about us and our software. Do a quick little discussion on the differences between our HECSTAB and HECSTAB software, and then we're going to really focus on what's new and what in our new software package HECSTAB. Condition definition, analysis packages and templates, and reporting. And then we'll just go through a number of different kind of hands-on examples and demonstrations of the software in operation. Little bit of background for those of you that don't know, Herbert-ABS Software Solutions is a joint venture between Herbert Engineering Corporation and the American Bureau of Shipping. So Herbert Engineering is a naval architecture company here in the San Francisco Bay Area. They've been around for over 50 years, and they've always had a very strong focus on stability software, both for their internal use and for providing to other clients. We are also, the HEC itself is kind of built worldwide at this point with satellite offices around the globe in the San Francisco Bay Area, Houston, Annapolis, Glasgow, Singapore, Busan, and Shanghai. So we've got a pretty wide touch on everything. And then I think most people know the American Bureau of Shipping, ABS, the American Class Society for classification of ships. So this joint venture happened 10 or so years ago, kind of in response to a number of things, but one of the main things was the Deepwater Horizon Macondo incident, where there was a expectation that there would be a higher focus on offshore stability and strength regulations. And so ABS wanted to, and was happy using our software and wanted to see what we could do to expand into the offshore business. And that's kind of what kicked things off. But since then, we've kind of just developed and grown together over the past decade or so. Right now, our main software packages, we do primarily 4 main software packages. HECSTAB, which is going to be what we're going to be talking about today. But we also have in our suite our HECSTAB software package, our CargoMax onboard loading computer system for ships, and our LMP offshore package for weight management and stability calculations for offshore vessels. So the first thing I want to talk about is just kind of this idea between HECSTAB and HECSTAB. I see a lot of names here, and many of you guys have probably seen or experienced or have used HECSTAB in the past. HECSTAB is just the natural evolution of HECSTAB, and in a lot of ways, it's kind of 2 sides to the same coin of a software package. So in our mind, HECSTAB is basically going to be the software package and the tools and approach that we use that's going to be focused on the naval architects that are using it for modeling, engineering, design, and evaluation. So doing things like regulatory stability assessment, doing things like damage and intact stability requirements, putting vessel documentation together, putting reports together, tank tables, loading manuals, and things like that. So it's focused on the designer, on the shipyard, or even on the class society to use to approve other people's designs and other people's analyses as well. On the flip side, HECSTAB itself is our package that we kind of focus on naval architects and salvors. And in a lot of ways, it has a lot of the same tools and a lot of the same approaches and a lot of the same user interfaces. But the focus on the HECSTAB side, and when we talk about HECSTAB, one of the main focuses is going to be on the emergency response aspect, doing things like rapid damage assessment response, doing things like emergency response and looking into calculations for oil outflow, for grounding in stranded situations, for planning of salvage operations and things like that. So we have provided HECSTAB for quite a long time. We've got a very wide software and user base using HECSTAB in what we would call our current HECSTAB 8.1 version. So when I talk about HECSTAB, the idea is that we're talking about the salvage side. If I talk about HECSTAB, we're talking about the design side. The other kind of thing to note here is that when we're looking at HECSTAB, we are doing this in a brand new development environment. We have we have our existing HECSTAB software that is robust and solid and confident in the version it has, but we realized that we needed to upgrade all of our tools and all of our environment to move forward for the next 10, 15, 20 years of all of our software. So we've kind of taken this HECSTAB development in our new next generation version of our code. And so that's what we're kind of focusing on here with the new releases at this point. So when we look at HECSTAB, what can we do on the ship side? We can do deterministic analyses, just doing things like simple intact or damage stability analyses based on writing arm criteria and things like that. We can do detailed probabilistic analyses. We can do ship's documentations and tables. You can do individual loading conditions that would go into TNS booklets and things like that. On the offshore side, some of the things that we've done for HECSTAB to focus on the offshore is basically we've made our software applicable for any type of vessel, any type of shape, not just ship shapes for offshore vessels. We've looked at jackups and semi-subs and round floating FPSOs and basically any shape that you can define, we can do a calculation for it basically. One of the main drivers we've had recently has actually been ABS itself, and we are in the process and working with ABS to have them use HECSTAB offshore as their internal tool for stability approval. One of the other main drivers for our HECSTAB offshore development has been this idea of a free twist calculation. This is when you're looking at stability for a ship shape, you're generally speaking, you're only looking at stability along one axis, the longitudinal axis. For some offshore shapes, the stability axes and how you rotate things and heel vessels over becomes a little bit squirrely depending on the hull shapes and things like that. So some of the more newer approaches are doing things like free twist or variable axis healing moments or healing writing arm curves as opposed to just having a fixed healing axis. So we'll look at some examples of those as we go through some of the hands-on presentation. So with all this said, we're really happy with what we've put together with HECSTAB and with our new modern version 9 package of our software. For those of you that have used HECSTAB for a long time, there's a lot of improvements that you'll see right off the bat. We've updated our programming environment in general. It's going to be a modern user interface. It's going to be a modern development that it'll look more like you're seeing modern programs look like. We're now able to take into account multi-threading, multi-core processors, which is going to greatly improve calculation speed and performance of the software in general. We've greatly improved the handling of large analyses. For those that have used older versions of HECSTAB, you might know that if you get to a point where you have too many conditions in an analysis that you're working with, things can kind of slow down. We're working on a database now with our new version where everything is it's not held in memory any longer, and so it's very easy to put together an analysis with 1,000 or 2,000 damage cases and easily switch between things, load things up, and delete options and things like that. So we've really improved the overall performance of the software in general. We've also done a lot to be very deliberate in tracking what changes are being made to each condition or each analysis node that you're looking at, and how that information is passed down to other conditions. I'll get into a little more detail on that a bit later. We have a very clearly defined API, so we do have we expect this to provide, or we expect in our package to provide a lot of UI and a lot of tools for our clients to use, but we also give a very large or very flexible interface for having those clients develop their own tools based on our software, where they can tie into our programming interface and write things in a Python scripting interface to do, you know, special analyses or one-off investigations or customized reporting or things like that. We'll go through a number of ways that we're already leveraging this API and this Python scripting interface. We'll also look at the flexible reporting options, and we have added, this is something that people have asked for a long time, undo and redo capabilities. So that's now built into the software now as well. So for those that haven't used our software before or haven't seen the overall package, I like to show this screenshot just as a quick overview of how things kind of fit together. There's two sides to our software package in general. There's going to be the modeling side, which we have here on the left. And there are options to take external 3D models from things like a DXF file or Rhino or other stability software and import them into our modeling software. But basically, our ship project editor is our main modeling software. That hasn't changed. For those of you that have used HECSTAB before in the past, the ship project editor is still going to be one of our main, is still included with the HECSTAB package basically, and is still used to do things like creating the ship project editor reports, things like vessel documents, hydrostatics, bond genes, capacity tables, tank tables, sounding tables, things like that. So everything here on the left side is relatively unchanged for HECSTAB. It's basically the same on that side. The interesting part is here on the right side where we have HECSTAB, which is going to be our main analysis interface, and we'll be looking at this very shortly. But you can feed into it a number of things. There's custom GZ editors, there's the Python or the script editor, there's analysis templates. These are all ways to kind of set up an analysis in HECSTAB. And then once you run an analysis in HECSTAB, you can get custom reports out of it and print the information, either view it on the screen or print it onto reports as you would like. So just a quick overview of our new HECSTAB main interface. As you can see, it is modern. We've got the new menu and ribbon bar across the top. We've got a main workspace down here below that's very customizable, but we still have some of the same things you're used to. A condition tree, we have graphical displays, we have entry forms, and we have a number of different ways to view results. We'll spend a lot more time on the interface once we get into the hands-on stuff. The one thing to note with HECSTAB is the idea of a condition. So the HECSTAB interface is going to allow you to set up a hierarchy of conditions, which is basically going to be, each condition is going to represent a single analysis. It defines the calculation parameters for that condition, your options, whether it's intact or damaged, your weight definitions, anything that you want to change or anything you want to investigate is going to be a setting on a condition. So the analysis tree in HECSTAB can do an analysis on one or more conditions. We also have this idea of condition tools, which is something that maybe instead of just having a simple setting or changing a weight or something like that, a condition tool can do something more complicated. It can do like a calculation to get you to a specific draft. It can do a calculation to evaluate a criteria. It can do an iterative calculation to find a maximum kg. It can create subconditions to look at different axes. So the idea behind this condition tools is that it's very powerful and very flexible to allow you to set up the condition tree and to set up your analysis in an efficient and accurate way. And again, we'll go through this process in the hands-on section here in a bit. But we do want to talk about the hierarchy of these conditions and the idea, and this is one of the main things and one of the kind of one of the primary things that we're looking at with HECSTAB is the idea of the condition hierarchy and the condition explorer and how things basically inherit down. So I can set up an analysis where I start with a parent intact condition. This is my top level intact condition. And then I can go down and define sub-children where everything kind of inherits from this condition down to my sub-child or into my child. But then I can change something on this step. And then I can add steps below that where things will change on that condition. And everything kind of just trickles down as you go down the analysis. And then if you come back, if you do a full analysis, but then you come back and say, well, let me change a few things here at the top, all of those changes will obviously then trickle down as necessary and as applicable through all the child conditions. And you can easily update and iterate on an analysis very, very quickly. A few other things to note, that on the HECSTAB offshore side, one of the main new features that we have is the idea of a free twist approach for stability. It's basically representing the path of least resistance, and it allows kind of offshore shaped vessels to heel and rotate as they kind of want to, as opposed to a free trim approach, which is artificially forcing a rotation around a specific axis. Analysis templates is another one of our main features here in HECSTAB that we've added recently. And you know, there is this idea that you can do everything in the user interface and set up an analysis by hand, but if you're doing kind of standard cookie cutter type things a lot, something like an intact max kg curve or something like that, then these analyses templates are basically designed to allow us to give you some templates, or you can actually, the users can create these on their own that basically just walk you through the process kind of in like a wizard type approach, where just the basics, just the things that you need to enter and define for a given analysis can be entered, and it can easily go through and set up analysis for you automatically. And we'll look at a couple of these as we get into the hands-on demonstration as well. So for example, we've added a SOLAS analysis template. I'll talk about this and kind of walk through a detailed analysis on this side as we get into the hands-on presentation. But this is just kind of showing some screenshots of what it would look like. And we'll do this on the hands-on side as well. And then finally, on the reporting side, we actually have, we're working on two ways to do customized reporting. We have a database reporting approach, and we're working on implementing a Python script reporting approach as well. And I'll show examples of both of those when we get to the hands-on as well. Moving forward, with this rollout of our new HECSTAB software, we are trying to build a community and to expand our user base and hopefully get them to share information and share tools and files that they've used in HECSTAB, so that there can be, you know, a central repository for GZ criteria, or people that have put customized reports together, or even advanced Python scripts that do certain specific things. We're trying to encourage our clients to use HECSTAB to develop tools that they need to use, and then possibly share them with others, and, you know, have access to what other tools other clients have provided as well. And then looking to the future, we're going to be working on HECSTAB for the foreseeable future, and you know, it's going to be the foundation for all of our software packages going forward. But in the short term, at least, what we're looking at is doing integrated direct calculation of wind moments. That's been a big feature that's been requested for a lot of our offshore users, and we're getting pretty close to having that available to send out. Just recently, there's been some movement towards the dynamic stability requirements, and that's going to be a kind of different type of approach on doing stability calculations, but we're looking at adding that to HECSTAB as well. And then longer term, we're looking at better ways to integrate and upgrade our software and integration with our onboard loading packages, CargoMax and LMP, including things like detailed container buildup, detailed container loading, advanced time sequencing, and detailed deck cargo tracking. So this is all looking towards the future, but there is a bit of a roadmap as we're going forward on this stuff. So that was a very quick presentation. This is our quarantined office, as you can see here in Alameda. I'm working from home. I think most of us are at this point here, but one of these days we'll get back in the office. So that's the quick presentation, and I think that what I'd like to do is just jump right into doing some hands-on examples. So I'm going to go ahead and start our new version of HECSTAB here. And the first kind of run through I want to do is just to give you an idea and an overview of what the user interface, the new user interface looks like, and kind of show some of the benefits and perks and interesting new features that we have in the software. So as you can see here, I hope everyone can still see my screen. This is the new HECSTAB user interface. So the first thing to note is that we've got on our back page here, HECSTAB is going to work off of 2 file formats. You need a model to work with. So when I started HECSTAB, I picked a model to load up that has all my ship properties and everything defined on it. And then any analysis that you do is basically going to be saved as or loaded up as a project file. So we're working on, if you're looking at it from like a Word or Excel standpoint, our HECSALV project would be similar to a docx or an Excel file or something like that. So I'm not going to load up any files for now. I'm just going to kind of show off the interface. We'll look at a number of different examples as we go along. In this case, I've actually loaded up a pretty interesting ship. This is our Herbert-ABS logo. We put this together in Rhino and imported it in. So again, not a ship shape. It's very, very interesting geometry, but you can see we can do stability calculations on anything that's basically defined as a volume. On the user interface itself, we can look at, we've got, the modern ribbon bar. There's lots of tools and ways to change what you're looking at and to get information. This is very customizable. We'll look at things like analysis packages where we can add items to the ribbon bar. It's context sensitive. So if I pick a tank, for example, I get a ribbon bar for how I can edit tanks. So if I wanted to damage my H or something like that, I could do something like that. Everything is context sensitive. As I click on items in the graphic, I zoomed in instead. As I click on items in the graphic, they'll show up here in my loads table, things like that. So everything is very interactive in the ribbon bar and in the interface itself. You can customize reports and customize things. Like I've put a couple quick items here for doing quick calculation buttons up here on the top. You can always hide the results bar as well if you wanted to show it. Just give you a little bit more room and space. Just kind of very basic things that kind of come with most modern software these days. We also have context sensitive help. So if I'm actually on something here in the interface and hit F1, it'll bring up the help menu. And as you can see, I was on my loads entry table, so it's bringing up the help context sensitive for that loads, the load view basically. So very modern interface, very modern just interaction. The other interesting thing with the way that we've put this together is everything that we're looking at in the workspace is very customizable. So everything is resizable. I spend a lot of time moving things around. If I want to zoom in or zoom out on something, I can move things and resize things pretty easily. But more importantly, it's very easy to move items around to see them how you want. So if I wasn't as interested in the graphics here, but I wanted to see my results, I could take this and move it over to the bottom here. So now I can keep my little graphic up here on the side, but I can actually look at my weight summary or my GZ summary instead. So let me run this analysis so I get a GZ curve. So I've got my graphics, I got my writing arm curve, I could look at my TNS summary, things like that. So every tab, every heading, every kind of interactive feature on here can be moved, it can be resized, it can be relocated. So there's a lot of ways to set up your view to customize it however you want. You can actually have floating windows as well. So if I just take this out and don't give it anything, it's actually a floating window now. I can resize this and kind of have this on a second screen if I wanted to. I just moved it off onto the other screen. So there's lots of ways to kind of customize the user interface to allow you to get the view and to get the information at your fingertips that you want. You can relocate, move around, floating windows. There I just showed you. You can actually have sliding windows, like the log kind of hides and shows. I could do the same thing over here on the results window. If I wanted to make that kind of a slide in out type of thing, I can do that. So that's the user interface in general. And for those of you that have used Hexcel for a long time, you'll see a lot of things that you're used to, but probably a lot of things that are going to be new. There is a little bit of a learning curve involved, but we think that there's a lot of improvements and a lot of benefits for the new way that we put everything together. So that's just the basic UI. Now I'd like to kind of look at a real analysis. So I'm going to go ahead, I'm going to close this, and I'll load up a different model this time. So this time when I start HECSTAB, I'm going to load up, I did this off screen last time. So this time it's asking for, an SH2 file. So I'm going to look at my semi-sub example that I have here. I'll load up my SH2, my ship model that I've put together previously. While that's loading. And then this time, I'm actually going to load an analysis package or an analysis project that we've put together. So I'm going to open a project. I've got a couple here. I'm going to start with this single case here. So this was an analysis that we put together where we basically started with a start condition. And then the first thing we did was actually just define a loading condition. So this is where I like to talk about the idea of the condition explorer and inheritance. So one of the really neat things that we've added here is I can actually see what my local changes are for each condition. So on this loading condition 1, I've set my wind source, I've set my percent full on all of my tanks, I set volume for these two guys. So I basically defined my loading condition. I added a GZ criteria as well. So this is everything that I've defined on my load case 1. So now that I've run this, I have a trim and stability summary. This is my overall stability results for this condition. Here's my writing arm evaluation. If I look at my alarms, I have my MODU criteria. So I have an evaluation here where I'm doing the MODU evaluation. I can see that I've got, if I look at the graphs, I've got a healing arm curve. I've got my GM, I've got my writing arm curve, I've got an area evaluation. So this GZ evaluation is very customizable. We provide lots of tools for defining all, we ship a lot of predefined ones, but obviously it's going to be impossible for us to stay on top of everything, but we give you tools to define these GZ criteria as necessary. But you can see here, for those of you that have worked with MODU before, it's a simple criteria that you're GZ positive up to your second intersection of your healing arm, and that you've got a certain area ratio. So everything here looks good. My alarms are passing. I don't really have any other alarms defined on this case right now. If I look at my load summary here, I look at my ballast tank, for example. Here's my 8 or 12 ballast tanks. I can see this is, again, a very simple loading condition where all my ballast tanks are full. My diesel oil tank's 95% full. I've got a chemical tank, methanol tank. So a very simple model in this case, but I've used my loads entry to define this condition. And I've done an evaluation. And according to my MODU criteria, this loading condition will pass. So now maybe the next step would be to do an analysis to look at damage stability. So I want to make sure that it's going to pass all of its damage stability requirements. So I could add a subcondition here called direct damage stability. And on this case, let's see here, on this one, I've basically made a couple changes. I've only really added a tool for my damage stability MODU criteria. And then if I look, I've kind of defined, I don't know, looks like about 30 or so damage cases here. So if I go to this condition, I can see that I've turned intact mode on for all of my tanks, and I've damaged NEOB, and then I've added a number of direct damage stability settings on here as well. So I've gone through and done this automatically, and you can kind of just see how this information is kind of passing down. So all of these damage cases are going to be built on this loading condition file up here and the starting condition, but then, you know, applying these new criteria or these new changes that are local to this condition. So that's kind of explains what the condition tree is about. The other thing that you can look at here is looking at different ways of reporting information from conditions. So I've put together a number of different results or a number of different reports that I can put together from this. So if I go to my file menu for print, I've got a couple of different options here. I could do a printout for damage cases, for example. So this is a report that we put together that basically just goes through and finds all my damage cases that I define and gives me a list of what their name is, what's damaged, and gives me a quick little graphic of it. So here's a nice little simple damage report. So here's one that has 2 damage tanks, so on. Compartment permeabilities. If this was one, if you were putting together a damage stability study, obviously one of the things you want to put in there would be the permeabilities that you use for the tank. A very simple printout you could add. The more interesting one would be like a one-line summary here. So we looked at all of these damage cases, and so we've pulled all these damage cases out, and we can see what the results are, kind of like a one-line summary for each, and we check that each one of these is passing its criteria. So this loading condition not only passes its intact results, but also passes all of its damage stability requirements as well. So this is all built on our database reporting approach. And this is all customizable by the user as well. So for those of you that have used database reporting before in the past, you can actually go in and edit or create these reports on the fly. So we give you an editing tool. If I wanted to edit this, if I wanted to add a new column or change units or change headings and footers or whatever, I can go in here and basically just modify the report as I want to. So there's a whole lot of customization that can be done here on the reporting side that we basically just give the clients the tools to do that. The other interesting part is we're also looking at ways to do reporting based on writing a simple Python script, and that would actually require us to go into our Python script editor. So this is one of our tools in our user interface where I can open a script to make a sample report generation. If I look at this script, I'm not going to get too detailed, but basically it's just kind of putting together. It says, hey, select the conditions, and then let's print the condition summary, let's print the alarm summary, print the trim and stability summary, weight and writing arm summary, and basically that's all it's going to do. So if I run this, it's going to ask me for the conditions. I could pick all, but I'll probably just pick, maybe I just want my damage cases, for example. So I can hit OK here, and this is going to spit out a report straight to Word. It'll show up here in 1 second as soon as it's done processing. Here it comes. All right, so come on. So here is the Word document that just got created by that Python script. It created a table of contents. It's got all of my conditions, each of my damage cases here. We ended up with quite a lot, 117 pages worth. And then for each condition, I've got my graphic, I've got my alarm summary, trim and stability summary, weight, writing arm. So again, very simple ways to do a report, but this could be something where, again, as a designer, if you're putting together a TNS booklet or a stability analysis, being able to very quickly put a Python script together that automatically generates a big block of these printouts and gets everything set up for you, I think is going to be very powerful and very useful for people to see. So that's the reporting side. We also talked about the idea of condition tools. So we've put a couple of condition tools on here, but I'm going to show you a couple others that we can do as well. So over here in my condition tree, I'm going to just add a child. This is going to give me a new one, and I'm going to call this one stability surface. So this is a tool that basically allows you to visualize the stability of a floating vessel around any axis, basically. So I've added a tool. I use my add tool up here. I've got my stability surface plot generator in my tools list now, and I can define that I want this to be a heel versus trim, and I'll just do the default run here, and I can run this condition, and it's basically going to show me once it finishes running, it's going to show me basically the stability surface. So naturally, if I'm looking at a kind of top-down view, I've got trim along one axis, heel on the other axis. So it's basically showing you how much energy it would take to get to a certain position. So for this ship shape, the diagonals are kind of strong, and the axes are kind of the natural axes are kind of weak. So if I was pushing in this direction, if I had wind or an overturning moment in one direction, there's obviously going to be a lot less energy or riding arm on this side as opposed to going along a different axis, for example. So again, just a very simple condition tool to show you. There's also a really interesting one that we can do. So like on this loading condition one, I'm going to add another child here just to duplicate it. And I'll call this a Python tool. So again, getting into what we can do with some of the Python scripting using our API here. I have a tool that I can actually just insert a script insert a Python script into a tool. So I know I'm going pretty fast. I don't expect everyone to follow along exactly, but this is basically just a script that's going to try to find the dynamic angle. So if I run this script, if I look at my my alarm summary, my MODU intact criteria analysis, one of the main things on this criteria is that it has to meet this ratio of restoring area to overturning area. So basically, the area above the healing arm curve needs to be more than, or 1.3 more than the area below the healing arm curve. And you can go all the way out to the angle of down flooding. So in this case, my intact condition looks very good. Everything is fine. I've got a healthy ratio. My angle of down flooding is 26.49 degrees. That Python script that I just added, what it actually does is it determines the dynamic angle, basically where I would have to limit my riding arm curve so that this ratio is going to be 1.3. So in this case, running that little script basically added on this dynamic angle calculation for me that basically says, hey, if for this condition, if your downflooding angle was 18.4 degrees, that's where you'd be at the tipping point of failing your criteria. So this would be something useful for like an initial preliminary design where you're not quite sure where to put downflooding points or how far in or where things can be located. This will give you an idea of, hey, as long as I'm outside of 18.4 degrees, it's not really going to impact my stability in this case. So again, just a very simple kind of example of adding a condition tool. Another really neat thing about our user interface and the way this hierarchy is set up is I can save this, I can copy and paste. So if I wanted to just copy all of these damage cases, I could copy this. It'll copy this and everything below it. So if I wanted to make let me do this first. I can actually just duplicate this entire tree. So if I had LC11, I could call this LC2. And in this case, maybe I just want to change my starting condition. So in this case, I want to go to my loads and just say, hey, on this case, these ballast tanks are actually 0% full. And now all of my damage cases are still going to be down below. All of everything that I've kind of set up below is still here, but now it's going to be running all those damage cases for this new condition. So I could run my active branch and it's going to start here and it's going to start going down. I probably expect some of these will start failing at this point, but maybe not. But it's going down and doing the evaluations, doing the calculations and everything like that. While this is running, another thing you might be nice to see from what you've seen in HECSTAB in the past is I can interact and I can pick different conditions. The calculation is kind of going on in the background, but I can actually change and look at results as they're running and interact here in the program. I'm not going to let it go through the full calculation. I'll go ahead and stop this. The other interesting thing that you can do is, if I have all of these damage cases, I can actually take this as a branch and I can save this out and I can use it for a different analysis. If I wanted to copy these damage cases, I could go File, Export. I want to export my branch and I would save that as my HIN. This is our export branch data. And then if I actually went and opened up a new analysis, so I'm going to go back and open up a new project. So if I'm going to open up this other project that I put together, intact off-axis max kg. So here's another analysis that I did. This was set up kind of looking at different drafts and then looking at different heading angles. So in this case, whoever put this design or put this analysis together said, okay, I need to get to a 30.18 draft, and then I need to look at my heel axis every 15 degrees around the tree. And I'm finding a maximum kg analysis for this. So this was something that someone set up here by hand, but you can do this in by hand. I could also, if I wanted to, for each of these, if I wanted to add a damage analysis to it, I could go on here and just go File, Import. I can grab those damage cases from this guy, and so now here's all my damage cases. So I could run, you know, the damage cases for this draft, and so on and so forth. So very flexible in how we can move conditions and move inputs and outputs around in the tree. And then finally, this analysis itself can be set up as an analysis template. I'm starting with a brand new project. Everything is blanked in my project. If I go to my tools menu bar, I have this analysis packages button here, and this allows me to add a whole lot of different flexible or kind of customizable reports. So one thing that we put together is an off-axis max kg package. So if I load this, I get a new ribbon bar, I get a couple reports and a data table. Well, the important part here is I get an analysis template. So I could walk through and do an intact max kg analysis very quickly. So I click this analysis template. It gives me kind of the step-by-step process for doing this analysis. So I define my variables. Just to speed things up, I'm going to make this every 30 degrees. I define my settings. Again, just to speed this up, I'm going to do a pretty minimal range of angles. I'm going to force a wind moment of 500,000. I pick my GZ criteria. I'm going to do this. I'm doing an intact analysis, so I'm just going to pick my intact analysis criteria. I'm going to define my draft set. I have this kind of saved already in oops, over here. I already had this saved. I can copy and paste it from Excel. I could enter it by hand, but I'm just going to copy it and paste it in here. So here's all my drafts. Oops, I missed a step. Forgot to switch it to metric or to English. Try that. There we go. Now we're in feet. So basically, very simply, I've only defined the specific things I need to do for this analysis. If I run this analysis now, it's going to set up my condition tree for me here, and I'm going to go ahead and get this kicked off. So I'm going to run all. You can see it set up a start condition, and now it's set up my first draft of 30.18, and now it's doing, you know, the sub conditions, looking at each 30, 60 degrees. It goes through and looks at things. It's finding the max kg. So for this one, at my 30.18 draft, my weak axis out of the angles I'm looking at would be this guy. We can see if we look at our writing arm criteria, we can see that this was governed by the area ratio. So I would expect in this case, our area ratio is going to be very close to 1.3. Yes, there it is. So we've gone through and done an analysis. It's doing each draft. It's setting up, you know, it automatically creates the condition for the draft. It creates all of the conditions for the different heading angles, and it goes through and calculates everything as it goes along. This is going much faster than I expected. I still have a lot of things I want to show, and I'm running out of time. I think I would like to move on to another example. I'll show you another. This was a very simple analysis package. I am going to show you a more detailed and complicated one that we've put together as well. So for anyone that's done a SOLAS probabilistic analysis for a container ship or a passenger ship or something like that, you know that those can be quite complicated. And again, we've tried to make it so that this, our analysis package and our analysis templates kind of distill that down into the very basics of what you need to do to define, to do a full SOLAS analysis. So I've already got this one pre-set up because it does take a little while to set up, but I'll open up a project where we've done a full SOLAS Reg 7 B1 analysis. But this one is pretty interesting because just starting off the bat, it took what, 5 seconds to load up. But if I look here in my summary, this is 1,500 conditions. So this is an analysis that already has 1,400 or 1,460 conditions. We can see that we've got 3 drafts: light service, partial, deep draft, and then for each of those, we've got, this one's got 440 children. This one has 500 damage cases. This one has 512. So creating all those damage cases by hand would be very difficult. So what we've done is we've put together the analysis package for this, and I'll load up this as a ribbon bar. So again, we've got a whole new ribbon that shows up here at the top. I've got an actual tutorial here where I can actually have a PDF that kind of walks me through the process of using this if you wanted to. This comes with the software. But the interesting part is if we actually look at the analysis package itself, or the analysis template, again, it's basically been distilled down into 5 basic steps. You define your variables, your max subdivision draft, maybe if you're doing starboard or both sides, however you want to do it. Some very simple analysis. You define your zone boundaries. Here's where a lot of the SOLAS analysis and iteration comes in, is defining your longitudinal locations and your deck and longitudinal breakdown and things like that. So we've got a whole interface for defining these things. Defining your stability calculations, just what angles, what writing arm curves you want to use. Defining your permeabilities. You know, for this one, there's some special cases for certain items that the permeability will change based on different drafts. So that's kind of built into this analysis as well. So as long as your model is defined correctly, it's pretty straightforward. You define your draft set. So all of this is you set this up once, and it'll run through and basically create this analysis and run all the analysis here for you. And then, you know, ultimately, if you wanted to look at your attained index summary, here's going to be the main summary, basically saying, here's your damage cases, here's your attained summary. Again, I don't want to go into details of SOLAS, but there's lots of tools that we basically kind of distilled it all down into the tools and commands and reports and things that can be used in the SOLAS analysis, and kind of just hopefully make it so that it's a very straightforward process to set up the first time. And then obviously the power of the software means that if you make changes, you can easily kind of go back and have all those changes trickle down through all the sub-conditions as well. I'm trying to speed things up here a little bit because there's a few other things that I wanted to go to. I saw a couple chats asking about whether HECSTAB will be phasing out HECSTS and HECSALV. HECSTAB is going to be replacing HECSTS. It's the same type of approach. If you've used the older version of HECSTS, the idea is that HECSTAB is that same package. It's the design package. As far as phasing out HECSALV, we are going to be maintaining both versions for, you know, kind of in sync for a while, but this analysis or this package can be used for salvage analyses as well. So I can do a quick example of a salvage example, what we have so far. So if I load up a VLCC demo, for example, and I'm going to load up I'm going to close out of my, I don't need my SOLAS anymore, but I'm going to add my analysis package for my stranding tools. So now I've got a list of items up here to do a single pinnacle grounding or a table of pinnacles, change tide sequence. I can open a project that I've already, not this one. Here's a simple project that I've put together where we basically kind of go through a very rudimentary analysis. So in a salvage, you would start with maybe what your departure condition was. Maybe you get this from the loading computer or you get it from the ship itself. And then you say, okay, well, on this case, I had burn off. So here my local changes are I've changed, I've put all these tanks to 50% full instead of 100 or 95%. And then I have possible raking damage, so I could do an analysis where I damage 3 tanks and say that they're damaged here along the side. I've got full outflow on all of these. Or I could say, oh, actually, I've got a bottom damage. So in this case, I'm turning on things like damage for these tanks. And I've actually gone through, and if I look at my loads, my damage tanks, so for my cargo tank, I've actually turned on my damage. I've turned on hydrostatic balance, for example, so I can still do things like that. I set my balance point at the bottom corner. The next step was I actually added a pinnacle. I've added a stranding. I use this one pinnacle grounding by draft that basically defined a grounding situation. If I look at this, let me bring this guy back over here. So we can see here, in this case, I've got a pinnacle down here on my graphics. I'm trying to get a good view, but I can't quite get to it. Based on this definition, here's where I grounded. I've got a ground reaction of 10,000 tons. If I look at my strength summary, I'm probably going to be way off the charts here where that grounding is. Obviously, there's a large shear there in that location. So anything you could do in the old version of HECSTAB for salvage and things you can, we're working on implementing them. The tools, and there's a lot of things in the existing version of HECSTAB that we haven't brought all the way over yet, but we are. The idea is that this will be HECSTAB and salvage response, emergency response package as well going forward. I have tools, again, running a tide sequence or running a script to figure out what tide you would need to free. All of these things are kind of built into this analysis package. Again, I'm trying to move kind of fast because I know we're running out of time. There was one last thing that I wanted to show. This is kind of, I saw some questions on the modeling side that popped up. The modeling is going to be the same between HECSTAB 8, HECSTAB 9, HECSTAB. It's all going to be using the same approach, but we are working on a couple of different things. One interesting thing with what we have with HECSTAB 9 and having access to our API is that other programs that use that allow Python scripting we can run scripts within them. So, for example, Rhino is a 3D modeling software package that has, here's a very simple model that's been put together. So if you wanted to do modeling in Rhino, you could do this. In this case, we've got a poly surface. I've got a cargo tank. I've got a hull defined. The only real consideration here is that we need closed poly surfaces or closed poly lines, I believe. So, I could use Rhino for my 3D modeling. I can put a model together like here. I've got 4 tanks. I've got a hull. I've got 1 spherical deck tank. If I look at my layers, I've got cargo tanks and a deck and a hull. So with a few simple kind of just Rhino setup and making sure that things are done right in Rhino, I can actually go into the Rhino. They have a Python script. I can run a Python script, and we've run an export ship project file. So this is a Python file that we wrote that's leveraging the HECSTAB API, but that's being run in Rhino. And basically, it's taking the geometry, it's finding everything that kind of meets the requirements, and it's going to export an SH2 file for me to work with. I'm going to replace this one, and then it's going to automatically start HECSTAB. And once it's finished loading, we can see that we've imported that model. We've now got the 4 compartments defined. We've got the hull defined. We've got this deck defined. If I scroll down, because I had my layers set up in Rhino, I actually end up with my deck tank and my 4 cargo tanks together. We expect to leverage this type of approach a lot more going forward with our modeling and improvements on our modeling side. We're working on actually getting full-on plugins within Rhino that will help kind of set up this interface, but also allow for calculations directly within Rhino and things like that. So there's a lot of ways that we're looking at integrating and connecting with other software out there, just based on the tools and capabilities we have with the new package. Whew. All right, I am at the end of my my presentation. I've got 2 minutes to spare. I guess for the panelists that have been answering questions, Justin, Keith, Brandon, are there any that maybe want to bring up while we have a little bit of time?
The workspace question was a good one. Might be worth talking about that briefly.
Okay, so the workspace, I'm assuming everything that I've been doing here, you've noticed, like maybe a little bit, maybe you haven't, but every time that I close down, it's saving all of these things. It's saving my fields. It's saving everything that I've customized in my view, everything that's been, you know, that I've set up my workspace. When I close it, you know, I've kind of done this a couple of times, moved my 3D graphic over here. You know, if I close down, start back up, even if I start up with a different model, if I go back to the VLCC demo, for example, it'll keep that workspace and keep that setting for you as well. All right. There was a question about can we show how to define tanks and compartments inside the hull? That's kind of fundamental to our software, and it's been available in our software for a long time, Gerardo. So that might be a webinar for another day, or a training for another day. But this webinar was mainly focused on what's new and improved, and what's coming in on the HECSTAB side. So, but as you can see, it did keep my views. It did keep my layout.
Gerardo also had a question about training. About
yeah, training.
How to get training.
Yeah, we offer training as requested by our clients. We don't have any set like schedule or anything like that. We kind of customize training on a per client and as needed basis. So for new users, we normally recommend a day or two worth of training, especially if it's an office where you've got multiple users. With COVID restrictions in place and you know, everything kind of up in the air as it is, we are offering and have done a number of online training sessions as well. So that is an option if you wanted to. It reduces expenses and exposure, but I think you can get a lot of the same benefits and a lot of the same you know, rewards out of doing online training.